let's move further. The next topic is called as the harmonic. It is the harmonic mean. Right. Now, if three terms, let's say they are in harmonic progression, then the middle term is considered to be the harmonic mean, or in general HM, between the other two, right? So let's write that. So if A comma B comma C in, right, harmonic progression, then the B is, right, HM here, just to indicate that harmonic mean is HM, right? B is said to be the harmonic mean of A and C. All right, now we defined what is a harmonic mean. Directly we will jump into the concept of a single harmonic mean of n positive integers, right? If we have the terms like A1, comma A2, comma A3, dot 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 up to AN are n positive numbers. If there are n positive numbers, then their harmonic mean is, right, say H equals to, this is n divided by 1 divided by A1 plus 1 by A2 plus 1 by A3 plus dot 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 up to all the terms, that is 1 divided by AN. So this total sum is going to, this whole expression, when you evaluate, you get the specific answer, that is the harmonic mean denoted by H. Now let us apply this to the term only if I have two terms, right? So the harmonic mean of A comma B is nothing but it is H. How do you calculate H? Now H is equal to 2 divided by 1 by A plus 1 by B. Let's take a common denominator in the denominator. So this is 2 divided by, there is a common AB over, this is B, this is A. So I can write this as, so the H is equal to 2 times AB divided by A plus B. Is the required equation to calculate the harmonic mean of any two numbers, AB, which can be given, right? Any AB given, you can calculate this. That's the first thing. Now, sometimes we need the harmonic mean of three numbers, right? Let us try to calculate that. So let's try to write the harmonic mean of A comma B comma C is H equals to, so this has to be 3 divided by 1 by A plus 1 by B plus 1 divided by C. So this is equal to, we have 3ABC divided by, the denominator there is A, so it gives a BC, right? So I can write AB plus BC plus CA is the required answer to calculate the harmonic mean of three numbers, A comma B comma C. Okay, let's move to the further, move to the next concept. Right here, we are trying to calculate the insertion of n different harmonic means. So I want to insert n harmonic means between any two numbers. Okay, so let A comma B be the two numbers, and let's say we want to insert h1, h2 dot 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 up to hn, right, are the n harmonic means. To be inserted between A and B. Okay, so this implies our basic knowledge of harmonic progression says that A comma h1 comma h2 h3 like that hn comma B should be in harmonic progression, right? So what is B? This implies the B will be basically, as per our notation, this is the n plus second term, correct? It is a n plus second term of the harmonic progression. So n plus second term of harmonic progression is nothing but 1 divided by the n plus second, right, term of the corresponding arithmetic progression. So how to write that? That is equal to 1 divided by, if A is a part of HP, 1 by A should be considered as the first term of the AP. Okay, plus it is n plus 2 minus 1 into D. All right, so my intention is now to calculate, all right, the B. Okay, so this is given as B, and now our intention is use the equation B is equal to 1 divided by 1 by A plus n minus, n plus 2 minus 1 into D. I have to use this to get the value of D. We'll try to write that answer in a different format. Okay, so let's, I want to calculate a D, which indicates I can actually bring the D to the other side. I can multiply. First step, it should be D into something. Okay, so I am actually multiplying the denominator to the other side. So bring the denominator to this side. So I'm going to get something like this. That is B into 1 by A plus, this is n plus 1 into D should be equal to 1. Now what I do, I will bring the B to the other side. So 1 by A plus n plus 1 into D should be equal to 1 by B. B will go to the denominator. So the next step, I want to have the value for D, right? Which means I can bring the A to the other side. So this is n plus 1 times D should be equal to 1 by B minus 1 by A. All right. So that means what is a D? D should be equal to 1 by B minus 1 by A whole divided by n plus 1. Okay. This is the easiest way to get the answer for D. Okay. Once we get the D, right, we know that we can write the terms like h1, h2, h3, right, from the basics, because we know that from the harmonic progression, I can write 1 by h1. My first term should be the first term of AP, which is 1 by A, plus this D value, right? So that plus D, that is 1 by h1. So calculate 1 by h1 and go for h1, taking the inverse. Then 1 by h2 should be the same 1 by A plus how many D's? 2 times D's. Right? So let's try to write this. Therefore, 1 by h1 should be equal to 1 by A plus the D value. What is the D value we get? Actually, you can see this can be further simplified. So I can take a common denominator. So this is A comes to this side, B goes to the other side. So this is A minus B divided by, common denominator is AB. So this is n plus 1 times AB, right? This is, right, the another format. Let's substitute this. So this is 1 by a plus d. So d should be a minus b divided by n plus 1 into ab. That's 1 by h1. How do you calculate 1 by h2? So 1 by a plus this is 2 times a minus b whole divided by n plus 1 into ab, and so on, right? Like the same technique, we can calculate even the 1 divided by hn value. So that is 1 by a plus n times d should be equal to 1 by a plus n times a minus b divided by n plus 1 times ab, right? General equation to calculate the hn, right? 1 by hn has to be calculated first because this is hp, and then we will come back to the hn by taking the inverse of that. All right, so the similar concepts we discussed even in case of ap and gp, same thing continues in hp. All right, so the next concept is that we use a theorem, right? The theorem states that this is very useful in solving many of the problems. So the statements of the theorem is that the sum of the reciprocals of n different harmonic means between any two given numbers is n times the reciprocal of single harmonic mean between the same, right? So we already know that, right? The h1, h2, h3 dot 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 up to hn are the n different harmonic means. So whenever I'm trying to insert n different harmonic means over there, so what happens? We know that the h1 comma h2 dot 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 up to hn are in the harmonic progression. So now the statement, let's come to the statement. Statement says that the sum of reciprocals of n different harmonic means. So what do you mean by that? It has to be 1 over h1 plus 1 over h2 plus dot 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 up to 1 over hn. This is what we want to calculate, and we will prove that this is nothing but this is equal to the n divided by the harmonic mean of a and b. That's what I should write, but anyway, we'll come back to it. Okay, now so this is nothing but this is equal to, let's apply the property, right? This can be written as n by 2 times, right? So we know that a plus l, a is the first term, l is the last term, right? So I can directly write this is 1 divided by h1 plus 1 divided by hn. Why so? Because I am using the property that is sum of n terms, in this case is n by 2 times a plus l. We had seen this in case of HP as well as AP, right? Okay, now, so this means now this is equal to, there is a n by 2, right? So you see that the first term, what is the first term? First term should be, right? Because I'll start from A and B, because I'll write even A comma H1 comma H2, right, up to the last term. So let me even write the last term. After Hn, so I have the next term coming in, please. Okay, so let me write that as well. So this means Hn comma B, right, are in HP. So I'm even including the B now. So the H1 is nothing but it's 1 by A plus D. That is H1 by H1. And what is 1 by Hn? It is nothing but the 1 by B, because inverse has to be taken when it comes to the arithmetic progression, minus D, right? So from that you subtract to come back to this Hn, 1 by Hn. All right, so that's how we write this. Now the D will cancel, this and this will cancel. So I'm having the term like, okay, let me simplify and write first. So this looks like n by 2 into 1 by A plus 1 by B. All right, what I do now, I'll try to write this itself equal to, this is n divided by, there is a 2. I bring 1 by A plus 1 by B to the denominator of denominator. So this is 1 by A plus 1 by B. Right? So I already know that, right? So the point which we are using now is, right, if A comma B are the two numbers, right, then what is its harmonic mean? Its harmonic mean is simply 2 divided by 1 by A plus 1 by B. Anyway, the simplified version, we already have it, right? So that is 2AB by A plus B. It's the same. So that is the proof, right? So n divided by, you can see the statement, given numbers is n times the reciprocal of the single harmonic mean. So reciprocal is 1 divided by, right? So n times, because it is n times the reciprocal. So we are getting the same answer here. So this is one important property. Okay, now let's move further. Let's try to solve a problem. If H is the harmonic mean of X and Y, find H plus X by H minus X plus H plus Y by H minus Y. Important question. Okay. So this is the question. So let's try to solve this. Now X comma H comma Y in HP, this is given, right? So what's the equation for H? We know that H can be found as 2 times XY divided by X plus Y. Okay. Now, so this implies I can calculate two terms. One is what is called as H by X. So H by X means move this X to the denominator. So I am going to get this is equal to 2y divided by X plus 1, right? And I can also calculate a term that is H by Y. So that is 2x divided by X plus 1. You can see that I want the term H plus X and H minus X. Right? Whenever we want to get that term, h plus x and h minus this thing. So we have to perform what is called as a componendo and dividendo technique, right? So directly let's apply that. So what happens now? So I want h plus x by h, sorry, not x, this is h minus x. So this is h plus x, and let's do this is h minus x. So this has to be equal to, so there is, when I do h, I can see that there is a 2y, right? So the x component is going to give you the x plus y. So h plus x is nothing but 2y plus x plus y. And when I have h minus x, you can see that h gives you a 2y from the above equation. H corresponds to 2y, x corresponds to x plus y. So that is the componendo dividendo technique. I just have to apply that. So 2y minus of x plus y becomes x minus y. All right, so let's try to simplify this. So h plus x by h minus x becomes, this is, okay, this is x plus 3y. Numerator, this is equal to x plus 3y. Denominator is y positive, y minus x. Similarly, I am trying to perform the other term required in my question. So it says that I need another term, that is, I think h plus y by h minus y. Let's just verify. Yes. So we got this term. I need to calculate h plus y by h minus y. Once again, I'm using the component to divide. All right. So let's apply. So this implies I want to calculate h plus y by h minus y. Okay. So do the same thing. The h can be represented simply, right, as 2x. And I need y, right? So y can be plus x plus y. And h minus y is 2x minus x minus y. So my answer will become 3x plus y all divided by, this is x minus y. So just calculate the required answer now. So this implies h plus x by h minus x plus h plus y by h minus y equals to, substitute x plus 3y divided by y minus x plus the 3x plus y whole divided by x minus y. So this is equal to, I can see that the denominators are negative of each other. So this is the x plus 3y divided by y minus x, y minus x plus, what I do, I write this as minus of y minus x, right? And this is 3x plus y. So this minus can be brought to the numerator as well. So this becomes x plus 3y minus of 3x plus y, and common denominator, this is simply y minus x. Okay, so apply this simplification. This is x to minus 3x is minus of 2 times minus 2x, x and minus 3x. Okay, simplify further, that is 3y minus y is nothing but plus 2y whole divided by y minus x. So this is equal to minus 2, I'll take it out, minus 2 if I take it out, this is y minus x. If I take minus 2 outside, then, one second, minus 2, so minus 2 into, can you take y, okay, just take 2 outside, sorry. No need to take the minus 2. Simply take 2 outside. Let's write it. Okay. So this is equal to, I'm trying to perform 2 outside. So this is y minus x. The denominator is also y minus x, right? Cancels out. So the answer is equal to 2, which is there in the answer. Okay, one of the option is 2. The next question. If A1, A2, A3 up to A10 in arithmetic progression and H1, H2 up to H10 is present in the harmonic progression such that A1 equal to H1 equals to 2 and A10 equal to H10 equals to, say, 3. Right? Find A4 into H7 equals to how much? Right. So they have given that A1, A2, A3 up to A10 in AP. So if anything is in AP and you know the first and last term, if you remember the common difference D can be directly found for an AP. How do you do that? That is A10 minus A1 divided by the number of terms n minus 1. So that is 9. There are 10 terms, n minus 1. So simply put, this is 3 minus 2 by 9. So I got a difference which is 1 by 9. If this is the case, how do you find the fourth term? That is A4, right? Fourth harmonic mean is A1 plus 3 times this. So 2 plus 3 times 1 by 9 is this, right? So 3 by 9 is 1 by 3. So 2 plus 1 by 3 is 3 to 2, 6 plus 1. So this is 7 by 3. So you got a A4 directly. Okay, go ahead and do the same thing for HP, right? So for HP, I'll give a different notation. So how do you find out the difference? Capital D is equal to, now it should be inverse. So 1 divided by H10 minus 1 divided by H1 whole divided by the difference. That is, right, it should be 9. 10 minus 1. Okay. So this is 1 by H10, that is 1 by 3, minus 1 by H1 is 1 by 2 by 9. So 2 minus 3 is minus 1 by 6 over 9. 6 into 9 is 54. So this is minus 1 over 54. That is a D. Okay. Now what is expected? H7 is expected. Right. But I cannot calculate H7 directly. I have to go with 1 by H7. Right. Just go back and check the equation. If you check the equations, we can calculate only the 1 by terms. You can see 1 by Hn I can calculate. So 1 by H7 I'm calculating using this equation. Right? But I don't have to use this because I know the D directly. So 1 plus Nd is what I want. Right? Simply apply this and let us calculate the 1 over H7 now. So therefore 1 by H7 equals to the equation I'll substitute 1 by H1 is the first number plus 6D, because starting from A it is 7th number, but starting from H1 this is the 6th number, right? So 6D, this is equal to 1 by 2 is the starting number minus 6 times 1 by 54. or 6 times minus 1 by 54 is this now. Okay. So this is 1 by 2 minus 1 by 9 is 18 by 7. Is it 18? No, sorry, it's 17 by 7 by 18, my mistake. That is H7, right? So this is 7 divided by 18. So 1 by H7 is that. This implies what is H7? H7 is equal to 18 by 7. So we got A4 and H7. So the question says that find the product, right? So A4 into H7 is nothing but 7 by 3 multiply with 18 by 7. So 7 cancels, 3 into 6, 3 6 there. So this is 6, right? This is one of the answers in the solution. Okay, all right, let's move on. Homework problem. Insert 6 harmonic means between 3 and 6 by 23. So you have to find what are the values of H1, H2, H3, H4, H5 and H6. A and B values are given and the AB values are 3 and 6 by 23.